Welcome to Statistics Learning Session. Today we'll be talking about chi-square test, specifically preparation that is required for chi-square test. And for chi-square test, we have under null hypothesis, if it is true, then if we multiply square root of n to p square hat p hat minus p naught, then it should be asymptotically normal. That is, it has to be Gaussian. Now let's move on to preparation that is required for chi-square test. What we have here is n square, that is n square square root of n and p hat minus p naught. This is a value that's been provided to us, and we need to transpose this p hat minus p naught, and we have to just transpose it right like this, and we're going to multiply by unit vector, that is 1 1 1, that goes on like that. Now what is equal to? Can you tell me? This should be equal to square root of n. That is square root of n, and this is a summation of j that runs from 1 through k. And in the bracket, we'll have p of j, and it's going to be a square, it's going to be hat, of course, and p naught, it also have a j subscript. In this way, this will be equal to 0, and this 0 is Gaussian. Why this is Gaussian? Because we know that Gaussian vector of all linear combination of the vector will give us a Gaussian random variable. And what we have here is a linear combination of Gaussian vectors. That's why the output must be a Gaussian, even though it is not a it is a degenerate Gaussian, but it's still Gaussian. Now let me give you an example why it's like that. Let's say we have n, a normal, and it has a variance as 0, it has a mean as 0, and epsilon as a variance. As epsilon goes to 0, then it becomes 0. So this is a concept, that's why it is based on. Now let's move on to the new one. Let's move on to some diagramming of how this would look like in the real world. Now let's see if we have a Gaussian vector, which is a normal Gaussian distribution. It would look like this, and it is a two dimension, of course. One, this is a y dimension, and this is x dimension. Now what we are saying here is that if one or two dimension is equal to 0, then all the points will span across only one dimension. That is, if let's say x is equal to 0, then what's going to happen is that this should be equal to like this. All the points will span in this direction. There will be no x, there will be only y here, and this is a degenerate Gaussian vector, but still a Gaussian vector or Gaussian distribution. There's no variability in y. That's what we are saying here. In the end, let me quickly summarize what we learned today. We learned about chi-square test, and chi-square test says that if null hypothesis is true, then p hat minus p naught multiplied by n square is asymptotically normal, and we need to do some preparation for that. So we did some multiplication of p hat minus p naught to transpose of that and multiply it with the unit vector, and found out to be a Gaussian vector, even though is a degenerate 0 Gaussian vector. This is what we got, and We also took some examples. We also did some diagramming of how it would look like in real world if we take a two-dimensional Gaussian and reduce the one of the dimension of a Gaussian and see how it works in a real life. And if that happens, then all the points will span in only one line. It's going to be a one line. So that's what we learned today. So thank you so much for listening. I'll see you next learning session. Thank you so much.